Hi everyone, and good afternoon, and thank you for joining our graduate program webinar session. My name is Ahmet Canmert. I'm a PhD student and a research assistant at the Electronics Engineering program of Sabancı University. In this session, we will provide information about 4 graduate programs. First of all, let me go over the content of the session. And in the session, the session will take 1 hour, having 2 parts. In the first part, which approximately take 30 minutes, our professors will introduce their respective disciplines. And in the second part, we will have a live question and answer session. For your questions, during the first part or during the question and answer part, you can use the Q&A box at the middle bottom of your webinar screen to ask your question. During the question and answer part, I will direct your question to the professors. Now we will start with our first panelist, Professor Kemalettin Erbatur. He will introduce the Mechatronics Engineering program.
Hello. Can we have that related first slide, please? I am Kemalettin Erbatur from Mechatronics program. Thank you for joining. Mechatronics itself is a multidisciplinary field with contributions from mechanical engineering, electrical engineering, electronics, computer systems, and control. So we have that wide spectrum of research areas in front of us. These can be related to the integration of those disciplines, or it can be detailed research on one of the components of those systems. Here we have in an alphabetical order the fields on which we are doing research and education. Automotive systems are investigated from a number of perspectives. Autonomous systems, energy aspects, and control of engines can be discussed in such an area. We are designing mechatronic systems, of course, from these various angles of control and mechanical design. Dynamics and vibration takes an important role. You need a controller to be embedded into a mechatronic product. So embedded systems, real-time systems, as building blocks of our overall mechatronic system are researched. Energy systems has also a large spectrum ranging from horizontal wind turbine design and implementation to fuel cells and the investigation of energy issues in automotive sector. Micro and nanofluidics is researched in our program, Mechatronics program. Heat transfer and cooling is an important topic. Machine vision is one of the sensor systems which is very important for robotic systems, and detailed research on machine vision is one of our research areas. Robotics systems and controls is studied and implemented by many of our by our faculty members. We have research ranging from haptic systems and exoskeletons to flying vehicles and legged walking machines. Topology optimization, multidisciplinary optimization of materials is also one of the research topics. Could we have the next slide, please? In the next slide, we have a list of our faculty members, again in alphabetical order. Adnan Kefal joined us recently. He is from the University of Strathclyde. He's working on structural analysis. Ahmet Onat joined us 20 years ago, one of the oldest team member. He's working on those embedded system on electronics and control. Ali Koshar is working on microsystems for cooling and for medical systems. Bekir Bediz is working on micro manufacturing and on vibrations. Eralp Demir, with a PhD from University of Aachen, works on mechanical systems and composites design. Güllü Kızıltaş from University of Michigan with her PhD. She is working on multidisciplinary design optimization. I'm working on industrial robots, industrial control, and leg robots, including quadrupeds and bipedal full body machines. Kürşat Şendur from Ohio State University. He is working on photonics and imaging systems. Mahmut Akşit, his PhD from Rensselaer Polytechnic Institute. He's working on energy systems, on various turbines for energy production. Melik Türkseven has his PhD from Georgia Institute of Technology. He's working on dynamics modeling and soft robotics. Meltem Elitaş has her PhD from Switzerland, EPFL. Her area is the micro-production of biological tools for medical applications. Mustafa Ünel has his PhD from Brown, ECS, and he is working on control systems and for vision systems and the integration of these systems. Serhat Yeşilyurt has his PhD degree in nuclear engineering from MIT, and he's working on fuel cells, energy systems, and also on micro robots. Tuğçe Yüksel from CMU, she's working on the energy systems of automotive machines. From University of Michigan, Volkan Patolu has his PhD. He is working on robotics, on cognitive robotics, on exoskeletons, and medical robotic systems for therapy. Thank you. This is my short introduction of our program and research topics.
Thank you, Professor Batur, for the great talk. And now we will continue with the Professor Murat Kaya Yapıcı, and he will introduce the Electronics Engineering program.
Ahmet, could you please move to the first slide?
This is it.
Okay. So, yeah, the first slide. In electronics engineering, if we look into the different areas that we have, I think we can go a slide back. The different areas in electronics engineering can be better understood if we look into the modern day devices that we use every day, especially in the era that requires us to stay at home. We typically make use of communication gadgets such as cell phones, or additionally things like PCs, televisions. when you look into these types of gadgets, we are talking about a complex systems. And a complex system is what typically electronics engineering faculty and research in our program is focused on. So if you look into the simple example of a cell phone, starting from the moment that one starts speaking and vibrating those air molecules, it hits transducing element, and somehow those vibrations are turned into an electrical signal in the analog domain, which is conditioned with specific circuitry and converted into a digital domain for processing. And later on, that processed information is sent through the air with the help of an antenna and, of course, modulation of electromagnetic waves. And the reverse story happens on the detection or the receiver side, where that signal is again down converted, and your voice is essentially transmitted to the. Now, if you look into a system like this, it's really quite complex, which involves both components and also connection of those components into a circuit level and then into a final product, which we refer to as the system. And in our program, we basically tackle both, starting from the component level up to the circuit level and also system level research. And when we look into these different domains, just like the example I've provided, it includes research in the domain of digital systems, electronics and circuits, primarily analog electronics, microelectronics, and as well as transistor level circuit design and also device design, which includes both semiconductor devices and microelectromechanical or non-electromechanical devices and systems. Optics and photonics is another part that our program is working on. Signal processing and telecommunications is also the other part of the system level example that I have provided. So as a whole, our curriculum is designed to be structured both to provide you the necessary theory as well as the practical application of these through our well-established laboratory facilities. So if you could, Ahmet, please go to the next slide. Over here, you are going to see the different faculty members that we have. Starting with the alphabetical order again, Ayhan Bozkurt is working on digital systems as well as design and modeling of microelectromechanical systems and driver circuitries for that, especially in CMOS, capacitive micro-machined ultrasonic transducers. Erdinç Öztürk is on the cryptography and security side, as well as computer architecture, FPGA design. Hüseyin Özkan is focusing on machine learning, computer vision, signal processing. Ibrahim Tekin is researching on microwave and millimeter wave circuits, as well as antenna design and RF circuit design. İlker Hamzoğlu is primarily on the digital hardware design side for video processing and compression, system on chip, application specific ICs, and embedded system design. Mehmet Keskinöz is focusing on data analytics, data storage, information coding, statistical signal processing, and information hiding, data fusion. Myself, Murat Kaya Yapıcı, I'm focusing on microelectromechanical systems, sensors and actuators, and especially process technology to realize those in a clean room setting. Ozan Biçen is working on artificial intelligence, telecommunications and signal processing, mathematical modeling. Özgür Erçetin is primarily focusing on communication networks and also network economics, mobile ad hoc sensor networks. And Özgür Gürbüz is focusing on communication networks, wireless communication and wide area networks, local and wide area networks. Yaşar Gürbüz is focusing primarily on microelectronics with different branches involving analog mixed signal circuit design, RFICs, sensors, actuators, and microelectromechanical systems. Yusuf Leblevici, who is also our president, is also have contributed to different areas of microelectronics, both digital and analog circuits, as well as MEMS devices. So this is an overview of our program. Please provide any specific questions in the Q&A session. Thank you.
Thank you, Murat Hocam, for the talk. A small reminder for those who just joined our session, you can write your question using the Q&A box at the middle bottom of your webinar screen. After the presentations, we will continue with the question and answer session. And now the Professor Murat Kaya will introduce Energy Technologies and Management program.
Hello, everyone. Energy Technologies and Management is one of our new and boutique graduate programs, different from all of the other programs that we are explaining today. This program is an interdisciplinary one. So at Sabancı University Faculty of Engineering and Natural Sciences, we don't have a separate energy faculty body. However, researchers, professors who are working on energy-related subjects have come together from different disciplines and created this boutique program. And the research areas of the program, as you see here, under 6 broad domains, reflect the research agendas of the related professors, as you can imagine. Let me describe what we mean by these shortly. And you will see that the topics are coming from at least 4 different dimensions, at least 4 different fields so far, and the number is increasing. The first area of research under energy technologies at Sabancı is power systems. Now, I need to explain what we mean by power systems because the name is general, but we are not doing a lot of things on power systems. We have a couple of specific research interests here. Under power systems, we are focusing as, this is coming from the industrial engineering domain, and we are solving optimization problems and decision problems of electricity or power systems. So we are not looking at power systems from a doubly electrical and electrics and electronics point of view, mostly, but from our current research is on industrial engineering domain, which is like optimization and decision problems in power systems. The second area we have is transportation. Here, broadly, we are doing 2 things. One is electric vehicles, which is, as you know, a very popular subject. This is about mostly about measuring and trying to improve the battery performance of electric vehicles. And the second transportation area is green logistics. Under the green logistics area, researchers from industrial engineering and mechatronics programs are working together. The third area, energy, conservation, and storage. This is coming from our material science program, which is quite strong in our university. As you know, we have 2 research centers, Sunum and KTMM, which is primarily doing material science research in addition to manufacturing. And our researchers are working on, under this topic, fuel cells, basically, battery management systems, and also energy materials. The fourth area is energy efficiency and harvesting. Again, this is coming from our material science group. This is mostly about developing ultra capacitors. The fifth area, renewable energy, covers our research works on primarily on wind energy, such as a vertical turbine design, or solar energy, again, which are quite popular subjects. And the sixth one, energy economics, policy and markets. This is, again, a very interdisciplinary area. I am working on this area. This is where we are creating energy models of the whole Turkish energy system and trying to answer some big questions like, okay, in the 50 years, in the next 50 years, how will the energy mix of Turkey evolve? What will be the implications for carbon dioxide emissions? How can government policies guide these scenarios, etc.? So from the 6 areas, as you can see, we are covering very different domains, bringing together expertise from different fields. And I shall re-emphasize that this is not a very large program. Under each of these topic areas, we are focusing on a limited set of research questions. The details, definitely you can find in our website. So if you are interested in the domain of energy technologies, please visit our website to check our current research interests. A couple of clarifications I need to make. The name here, Energy Technologies and Management, is somewhat misleading, and actually we are going to be changing this soon. It's going to become Energy Science and Engineering. The reason being, the management word here can give prospective students a misunderstanding. We are not doing management here. We are focusing on science and engineering of energy. Another clarification, we also have another program with the same name, Energy Technologies and Management, but that one is aimed at professionals. It is a non-thesis program aimed at professionals. This one with the same name, this is the with thesis version. This is the more academic version, basically. So sometimes people apply to the wrong program, so we want to clarify that. The one we are talking about today is the academic version, Energy Technologies and Management with thesis program.
Murat Hocam, we cannot hear you.
Sorry. The faculty members associated with the Energy Technologies and Management program reflect the variety, as I mentioned. 2 of our members are material scientists, Professors Emre Erdem and Selmiye Gürsel. 2 of our faculty members are industrial engineering faculty members, Murat Kaya, myself, and Burak Kocuk. We have 1 physics faculty, İsmet İnönü Kaya, and also 2 Mechatronics Engineering faculty members, Serhat Yeşilyurt and Tuğçe Yüksel. So, as I mentioned, this is like a interdisciplinary program. I mean, why would a candidate, why should a student choose this program rather than choosing our parent programs, for example, industrial engineering, mechatronics, or physics? Well, the idea is that if the candidate is sure about focusing on an energy-related subject, choosing this program will provide the candidate with more flexibility in terms of the curriculum. Because in this program, because it's interdisciplinary, the course requirements are much more flexible. And also some candidates might prefer having the name Energy Technologies in their diploma. So if you have questions about the detailed projects we have or potential coming projects, please feel free to contact us. Thank you.
Thank you for the talk, Murat Hocam. As a last talk, the Professor Lütfi Taner Tunç will introduce the Manufacturing Engineering program.
Okay, hello. First of all, the thing about manufacturing engineering, maybe we can start with a question that have we ever seen a product or a thing which has not manufactured? So it basically we should think in a way that every thing we see in our lives are manufactured in a way. So thanks to the previous speakers, because in manufacturing engineering we deal with from the process level to the manufacturing systems level indeed, so which will involve a really very tiny bit, which may be cutting the, for example, material. Then if we consider a manufacturing system, it is basically kind of mechatronic system, which has embedded controls, all the moving systems, and also electronics, and also they are using energy actually. So the idea in manufacturing engineering is basically taking the, for example, energy by using different kinds of manufacturing systems. We want to utilize different kinds of manufacturing processes to realize, for example, the dream of a designer, because on the screen, on a 3D screen, it is still not real. It is just a design. Then we want to convert this design into real working systems, real working parts, for example. So in this context, we can say that design and manufacturing, although the name of the program, is manufacturing engineering, we take design and manufacturing on as going together actually, because to manufacture something, you need to have an insight about this design, and to design something, for example, design a part, let's say, it may be for example, aesthetic purpose to a really very high-tech purpose. You need to know kind of manufacturing processes. So our vision is basically taking design and manufacturing all the way together, because they are feeding each other. So when we, and also, if you want to talk about the history of manufacturing engineering program at Sabancı University, the first manufacturing processes have been started to be dealt with at Sabancı University at the Manufacturing Research Laboratory since 2004. But at that time, it was part of industrial engineering. And since 2015 or 2016, we have been now, we have just launched this new program as manufacturing engineering. So when we look at our research areas, we involve additive manufacturing and also 3D printing, which is really enlarging the vision of designers. So by using additive manufacturing, you can manufacture different geometries, which may not be possible to manufacture by using conventional methods like machining, let's say. Then when we talk about parts, they are mostly divided into two in terms of their materials, obviously metals and plastics. So when we look at the plastic side, we deal with composite materials, their design and manufacturing as well. So we call them advanced composite materials because we aim composite materials which may be used in, for example, aerospace industry, let's say. And also in regards to additive manufacturing, we have faculty members dealing with biomanufacturing and also 3D printing, which is linking us to organ printing. And also when you look at for example, machining process, you may need to integrate your research with CAD/CAM systems. When we say CAD/CAM, it is basically computer-aided design and also computer-aided manufacturing. So at the computer-aided manufacturing context, you have an idea about a manufacturing process, and then it is a tool to just let you command that manufacturing system, which may be a CNC machining system or a robotic manufacturing system. You program it through a computer-aided manufacturing, let's say, software like CATIA or Siemens NX, let's say. So then you need to integrate your methods with these systems, at least to have a, let's say, working simulation systems, for example. So in the design side, in our program, we deal with computational methods like finite element methods or maybe some other analytical methods, and also then in a conventional manufacturing process, we take machining basically, because what makes special machining is that it is almost the near end like process. So it is almost the end of all the manufacturing processes, and it is really very flexible. So you program a CNC machine to manufacture a free-form surface, let's say, or a prismatic part. So then it's also very versatile. You may be using different cutting tools for different purposes. So you may be making different parts like composites or maybe metals, different kinds of metals, and so on. And also we aim to apply all the research outputs in real case studies. So in, for example, industry supported projects, or maybe some sort of TÜBİTAK supported projects, European Union supported projects, for example, we always aim to use real case studies from industry. It would, for example, I hope, or at least we think that it is increasing your understanding how an industrial outlook is. It is basically, I just wanted to cover all the research areas in a given framework. So if maybe we can move to the next slide, I may be like talking about our faculty members who are making up the manufacturing engineering group, or like program, let's say. We have Adnan Kefal, and he is working on computational mechanics and also structural health monitoring, which is quite important for big structures, which may be undergoing like cyclic fatigue and so on. So you may be using sensors, for example, to monitor the health of structure. Bahattin Koç, he is also acting as the director of Composite Technologies Center of Excellence, the Sabancı University Integrated Manufacturing Research and Application Center. His research areas involve mostly bioprinting, additive manufacturing, and 3D printing of like multifunctional structures. We have Erat Demir. He's working on crystal plasticity, FEM, finite element methods, and also physics-based modeling of like most manufacturing processes. Aram Budak is mostly working on CNC machining processes, machine tool structures, machine tool design, and also wide variety of machining processes, but he is working on only metallic parts, let's say. And myself is, I'm working on 5-axis milling processes, which is a very vital process in manufacturing of jet engine components. For the last, I think, 4 or 5 years, I moved my research on robotic manufacturing, specified on robotic milling techniques, because when you want to deal with very large parts, which is in composites, it is an important area. It may be important when you want to manufacture a part up to 2-3 meters. Then using a CNC machine may be quite costly. And also, I'm also dealing with process modeling and CAD/CAM systems. We have Professor Mehmet Yıldız. His major areas computational fluid dynamics. So he's applying all the theoretical knowledge on, let's say, composite manufacturing processes. Let's say, like, for example, resin transfer molding and so on, and all different type of composite manufacturing processes. We have Mustafa Ünal, Professor Mustafa Ünal. He's dealing with his area. His link with manufacturing engineering is basically he's working on integration of systems, vision systems, sensor systems with manufacturing system. And last but not least, we have Professor Yusuf Mendeloğlu. He's working on polymeric materials, because when you talk about, for example, plastics and also composites, the minimum size, or like the building block, is basically polymer. So he's working on development of polymeric materials and also nanosize. Considering the time, I'm stopping here now. If you want to have more information, you can email us or like directly ask your questions, and also visit our website. Thanks for your time.
Thank you for the talk, Taner Hocam. And now we will continue with the question and answer session. Again, you can ask your question using the Q&A box at the bottom of your screen.
I think we already have some questions over there.
Okay, I will now The first question is for the electronics engineering. When the earlier application results will be announced in the Master of Electronics Engineering?
I think this year, the earliest that we would be able to announce the results would still be by the towards the end of June or early July.
Okay.
The side note is that for the specific pandemic that we have this year, we are going to have applications also later in August for those who may have missed the application deadline, and that will also require, of course, complete applications with documents.
And a question related to this topic also: how is the interview process will be?
So I think the interview process could have some variations from program to program. If the specific question is for electronics engineering, we typically have students interviewed, of course, in English for about 15 to 20 minutes max. And we ask questions to understand the level of knowledge and background that the applicant has. There can be both technical questions and there can also be some generalized questions to understand what the applicant is interested to work on for their master's or PhD studies.
Thank you for the answer. Another question for the energy technologies and management. One candidate said that I graduated with a bachelor's degree in engineering area. I want to know that, is that possible? I got rejected because of the curriculum of my bachelor's education.
Well, the applicant says engineering area, but which engineering area, it's not clear. In general, we don't reject people directly because of their, undergrad's degree. We take it as a whole. I mean, is there a connection between the career goals of the applicant, his or her background, educational or experience background, and our program? I mean, can the applicant provide the link between what he or she wants to do, what he or she has done so far and learned so far, and the relevance to our program, of course. As long as there is a meaningful connection, there is no reason to reject anyone because of the educational background, especially if you have an engineering education, of course.
Thank you, Matujan, for the answer. And another question for the Mechatronics Engineering. One applicant said that I have submitted my application, so do we need to contact with the professors in advance?
Let me answer this question telling that yes, contacting professors in advance has a certain advantage from the scholarship point of view. Some of the professors have open projects with open positions for graduate students. So for the stipend type of scholarship, it may be important to contact professors before the evaluation process, before the interviews. Contacting professors isn't a must. However, it could be good. Also, visiting our website for the research areas of the professors would be advantageous for you. But also note that not all the open projects and scholarships are listed there. Some of them could be quite new and not in that list. The most up-to-date information is what you can obtain from the professors. So do contact with them. This is a good idea.
Thank you, Professor Erbatur. And there is another mechatronics question. And the candidate said that I am a mechanical engineering about to graduate. So will there be a problem for differences between mechatronics and the mechanical engineering curriculum?
if you look at our faculty members, their undergraduate disciplines, their graduate disciplines, about half of them are from mechanical engineering. So mechanical engineering background is a good point to start into the mechatronics engineering research. If you are a PhD applicant, you should know that there will be a qualifier examination after you take your courses, and that qualifier examination is multidisciplinary as mechatronics is. You should acquire and you should be proficient in subjects other than just mechanical engineering in the short future, but mechanical engineering background is a suitable background for mechatronics engineering graduate studies.
Thank you for the answer, Hocam. And here's a question for the Taner Hocam. From which fields and which type of questions will we ask in the manufacturing engineering graduate interview?
In like manufacturing graduate interview, as I said, it involves really different research disciplines. So we don't have very like well-defined like technical questions that I can say that it will be from materials. So it really depends on your interest, because when we say manufacturing, your background may be on material side, and then you may be dealing with, for example, let's say develop the polymers, or it may be machining processes if you have, for example, mechanical engineering background. So it really depends on your interest. So first of all, like usually we do it like that. You just first explain yourself, what you are interested, why you want to pursue a master or PhD degree. Then we just understand that you are just, for example, you have an intention in a research area in the manufacturing, for example, framework. So then the questions will be mostly about your background mostly. So if you are from materials background, you will not have any questions about the mechanicals or like machining processes, let's say, or like vice versa. So it really depends on your intention of your research. If that answers the question, if not, I may maybe try to explain more.
Thank you, Hocam.
Okay.
There is another question about energy technologies and management. The candidate asks that the specific research projects in the energy technologies and management program that will be worked on for the upcoming semester, specifically on the power systems.
On the power systems, let me re-emphasize, when somebody says power systems, the first thing that comes into mind is electric engineering, right? But we don't have that type of research here, as far as I know, right, Murat Kaya Hocam? We don't do power systems research in electrical engineering program, as far as I know. What we mean by power systems, there is the modeling of planning, modeling, optimization of power systems. You can check Hoca's website. He has a number of ongoing projects there. This is what we mean by our power, the power systems research in our energy program.
Thank you, Hocam, for the answer. There are some common questions. It's like one of them is, if you are working in industry, can we find a supervisor for the master program? So one question is specifically for the mechatronics engineering.
Yes. Let me answer them. Not just for mechatronics engineering, but for other disciplines as well. You can be working and studying towards a degree, graduate degree. This is per an agreement with the organization you are working at and the university. it should be stated that a certain percentage of the student's time can be spent at the university, and he or she will be allowed to go on with the work too. There are such students, and they can find supervisors. There is no problem in that. The procedure is open for such studies.
Thank you, Hocam, for the answer. Another question for the Mechatronics program. Are the Mechatronics students eligible for the university full scholarship, or it's for only some programs and the Mechatronics only can benefit from the project scholarships?
The way to full scholarships is open. However, there are programs which receive more full scholarships. There are programs which receive less scholarships. Still, there are possibilities to have full scholarship supported Mechatronics graduate students.
Thank you, Hocam, for the answer. And there are some questions about the GRE exam. The one is that can we get rejected due to the result of our GRE exam for our application?
Let me answer this. Definitely you can. There are very clearly stated minimum scores to make you eligible for application. If you don't have a score higher than that, you won't be considered. However, this year, because of the coronavirus epidemic, as you know, a lot of exams have been postponed. People are having difficulty getting their scores. The solution we found is this. If your application package is good and you are only missing a GRE score, let's say, or ALES score for Turkish applicants, then if you are really good enough, we can give you some sort of a conditional acceptance, which means, okay, if you can bring us a GRE score that is higher than blah, blah, whatever the number is, then you will be accepted. And we know that the earliest ALES exam scores will be available in mid-September. So if you don't currently have an ALES score for Turkish applicants, and if you won't be able to enter into alternative exam as well, you can have asked this question, because there is no way I can get a score at this point. Well, if you are good enough in terms of your application package, you can get a conditional acceptance. And then if you can provide us with at least the minimum required score, you will be accepted. The details will be available in our application web pages.
Thank you, Hocam, for the answer. There are two questions for the electronics engineering program. The first one is, what fields are covered in optoelectronics? And the second question is, are there any projects in the field of organic LEDs, LEDs?
So in optoelectronics, we have topics about basically dynamic diodes, photodetectors. These are solid state optoelectronics. We can also have some research work on fiber optics as well. In regards to the specific question on whether we have an active research project on organic LEDs, there may be, but I'm not sure if this is a significant priority or a contracted research project of any of our current faculty members. And to follow up also on this question, I would like to make a recommendation to all applicants that are interested in our program to go over and look into our web pages of each of our faculty members to get a better idea of what type of research we are working on. Also, the university has created a web page that shows active funded research. If any of the applicants are interested, we have a list of projects, which is not, of course, an exclusive list. There can be other projects that are not listed on there. So the takeaway message here is please do your research well in order to get a better understanding of what each faculty member is working on, and try to keep your options open. Sometimes we have candidates approaching us fresh from bachelors, and maybe they have studied only communications or let's say power, but in really the interviews we try to understand whether we and the program, whether the candidate and the program has a match or an overlap. So it would be helpful if you can try to go through our web pages and see if any of the research we do matches your interest. Then we can have a better idea about your suitability to our program. So that is a recommendation, and maybe a little bit of homework assignment on the applicant side.
Thank you, Hocam, for the answer. And one question for the energy graduate program. What are the job prospects for an energy graduate student?
Well, let me differentiate between our two energy programs. Again, the one that we talked about today is the academic program. So if you are coming here, you are either interested in going to a PhD program, or probably you are interested in working as a research related industry. So if you are coming to this program, the job prospects are, academic career, definitely, or at a design center, research center, or a company which does higher level, research related work. That would be the ideal career opportunities. If you are more interested in energy business, on the other hand, if you want to go to some Turkish company, and do standard engineering or, sales, finance, purchase planning of energy, business related stuff, then we have this other program, which is a program for professionals. It's like an energy MBA type of. That would be good for people who are more interested in the business careers.
Thank you, Hocam, for the answer. There's again a general question. If you have been already awarded a scholarship, let's say by TÜBİTAK, what are the chances of acceptance?
If you like, I may shortly answer it. If you have additional scholarship from TÜBİTAK or from any institute, it's a plus actually, because it is just in like two or three different ways. The first way is it shows that your credentials are okay and above the bar, let's say, and also you will have some sort of scholarship, which means that you will be financially quite a bit of like secure, and then your support or your request for support will be quite less from us. So it will help actually for your application packages, in my opinion.
Thank you, Taner Hocam. There is also a question about the difference between the industrial engineering program and the manufacturing engineering program. What's the difference between an industrial engineering program and manufacturing engineering?
If you like, I can answer again, Murat Hocam. So, I think I may be the good choice to answer it, because I have a mechanical engineering Bachelor of Science, industrial engineering Masters and PhD, and I'm dealing with manufacturing processes. So the basic difference is that in industrial engineering, the research is mostly in development of kind of optimization algorithms in different cases. It may be, for example, continuous systems, discrete systems. It may be stochastic systems, let's say. So they are mostly dealing with operational research or development of optimization or some sort of heuristic type of algorithms. So they are mostly at the mathematical side. So they are not dealing with mostly specific manufacturing process. They are not specific to the process of the case. Okay, so any algorithm developed by an industrial engineer may be applied on manufacturing, may be applied on management, may be applied on, for example, portfolio management in like finance, let's say, or in management of a hospital, let's say, or a, for example, airline company, for example, gate and plane assignment, for example, air crew management. But when we move to the manufacturing, it has a very strong application area of like manufacturing process. You may be applying industrial engineering approach, but it should be related to a real manufacturing process. It may be machining, composite manufacturing, it may be manufacturing systems, it may be process monitoring, but it has an application of design and manufacturing of like real parts, real, for example, manufacturing technological systems and so on. I hope it helped. I could answer the question, I hope. So to sum up in one sentence, at the industrial engineering side, people are dealing with development of algorithms or approaches or like methods to improve a system where the system is not specific. But when we come to the manufacturing engineering, we deal with manufacturing processes, manufacturing systems, and also design of the part you will be manufacturing. So it is basically very distinct, I can say.
Thank you, Hocam. Thank you for the answer. And there's a question for the electronics engineering program, but it may apply to other programs as well. The interview will the interview be by my mentioned professor in the application form, or by the whole committee members?
No, I think the interviews are typically done by committee members in general, not by a specific person, but it is highly suggested. I think there was also a question that what to include in the statement of purpose to identify specifically if there are any research areas or professors that you are interested to work with. It makes our evaluation easier. But the interview itself is going to be with a panel of faculty members in EE. I think I may probably make a suggestion, if possible, to go over question by question, specifically that because I see now that most of them are general questions, and start answering them.
Yes, there's a one specific question for the Professor Erbatur.
Yes.
As I know, Kemalettin Erbatur is working towards the robotic field. Can he tell us the lab environment and opportunities of his field inside the Sabancı University?
In my research lab, at the moment, there is a full body humanoid robot, 29 degrees of freedom, Sural. It is still serving for our humanoid robotic research, including full body motion control. There is the Surkan, a newer robot, hydraulically actuated quadrupedal robot. There are industrial robot structures. There are mobile robots. We are working recently on a tracked vehicle. We have also our own designs of simulation software, full dynamics, including contact models, full dynamic simulation packages, on which we are researching on the control aspects of various robots, including the legged and industrial ones. There is such a research environment. The topics range from control to reference generation of those robots to industrial applications. Thank you.
Thank you, Hocam, for the answer. Now there are mostly the generic questions are left. One question is that I have sent a lot of email to professors regarding the research position, but did not get very positive results. Should we secure a supervisor before the application?
I think that my answer to this is it is helpful, as Professor Erbatur outlined, to contact professors regarding research positions. Even if you don't get very positive results, it may be that the professor didn't have time to respond. So it's not a must that actually you secure a supervisor before applying. That is not an indication that you are not going to be accepted, or you are actually going to be accepted. So the answer to that is you can send emails irrespective of whether you have an answer or not. It is always helpful.
Thank you, John, for the answer. Another question: how can I look at the projects? What's the best way to learn about the project of a research group or a professor?
I think we have now a website on the fans, as Kemalettin Hoca said. So there is a list of like projects which may not be up to date to the like very recent projects, or they may be updating like continuously, or you may be like directly contacting the like program coordinators to ask more information, or you may be directly contacting the, for the FANS Dean office, so that they may be directing you to the website where you can see all the projects undergoing within the, for example, let's say manufacturing engineering or overall in the FANS.
Thank you, John, for the answer. Another question is that, do you consider integrated master programs like in the UK and Canada MS programs?
What is meant by do you consider integrated? I understand that the question is about masters plus PhD dual.
As I understand, it's like a part of the program is in the Sabancı University, and the other part is in the let's say another university in the UK or another.
So the only thing that I know is regarding our program, EE has started to establish a dual program with one of the universities in Asia, and the details of that will be announced soon. But that is for typically, I think, the PhD program, if I'm not mistaken. Apart from that, I'm not sure if there is a concrete agreement between two universities, Sabancı and another university, for a dual diploma program. I think EE may be the first to start this, and I'm sure maybe in the future other programs will do that. So definitely the university has some initiative to offer dual diploma programs, and it will start, but it has not been announced yet.
Thank you, John. Maybe this is a question from me. How do the professors see the summer internships for their master and PhD students?
In my opinion, in general, it really depends on the case. For example, if you have done a really very good hands-on experience, or like theoretical, or like vice versa, or like both of them, type of like summer internship, if it is giving you an understanding about the research area you are applying for, it's always useful. Because when you are studying, for example, Bachelor of Science, you learn some fundamentals. Then in like kind of industrial like research, you learn their like real life applications. So before any research program or before any research experience, if you do some sort of practical and also theoretical summer internship, which is really very full of like things around your research area which you are applying for, I think it will be useful, I think.
Thank you, John, for the answer. A question for the electronics engineering: will there be an application period for the spring semester for the master program?
The deadline is the same as the rest of the FANS programs. The early application deadline is 22nd of May. Late application deadline is 18th of August. We are talking about the fall, or did I misunderstand the question? We are
Yes.
talking about the next semester, correct?
Yes, yes, exactly.
So the same deadlines apply to all programs.
Thank you, hocam. A clarification for the previous question. The candidate said, I meant the MENG programs, like in the UK, it's integrated masters and it's different than masters.
Okay,
Nice.
I understand. Now, those types of programs are usually 5 years, or it's integrated with bachelors, I think. That's what the applicant is asking. And please correct me if I'm wrong. We do not have that type of a program, Master of Engineering with bachelors integrated. We don't have something like that. We have masters, non-thesis, I believe. But with bachelor's integrated program, we don't have. And I hope I understood the question correctly.
Thank you, hocam, for the answer. A question related to the previous question is it common a professor refer a students for a summer internship?
So my answer to this is really depends on the professor. Usually, if the student is working on a research project, especially, the expectation is that the student focuses on his master's thesis. Apart from that, sometimes our faculty members offer or recommend students to go on to internships if they are directly or somehow linked with their thesis study. But this is something that really depends on your thesis advisor.
Thank you, John, for the answer. The rest of the questions are about the delay and the cancel of some application exams due to the coronavirus pandemic. So the one of the questions, can we apply with without a GRE result or a language exam result?
I think we already answered that question. Yes, you can, but we will still evaluate your application. However, we cannot accept you without this course officially. If your package is really good, and we can give you, in the best case, a conditional acceptance, like, okay, you need to complete your GRE score by this date, and it has to be at least this much, then you will be accepted. But I mean, because of the pandemic, we will be flexible in accepting applications without certain exam scores.
Thank you, Hocam. Thank you for the answer. I think there is no more question. Do you have any comments? Do you have anything to add for our candidates?
Let me re-emphasize something Murat Hoca and Kemalettin Hoca already mentioned. When you are applying for a program, this can be Sabancı or any other institution, make sure that you study the program, okay? So you know what kind of topics are being studied there, what kind of projects, who are the people, who is doing what. Do your homework and reflect this homework, reflect this research of yours, I mean, in your SOP, Statement of Purpose. Statement of Purpose is a very important document. It shows you, how hard you have thought about your application. And the Statement of Purpose shall not be a generic document, okay, with some blah, blah, empty boilerplate sentences. It has to be specific. Tell us the relationship between three things: your past, your future goals, and the Sabancı University program that you are applying to. How are these three things connected to each other? And be specific, okay? Aim to about 1 or 1.5 pages. Don't make it too long. And again, throw away all the garbage, focus on specific things, okay? When we read your SOP, we shall say, okay, now here is someone who knows what he or she is talking about. That would be a big plus for your application package.
Thank you, Hocam. There is also another clarification for the previous question. The candidate said, I mean, if you accept this integrated master program, do you accept it as a master in admission, or do you accept it as a bachelor's degree, or do we need an extra master degree?
I really am not. Go ahead.
I think this is about applying to PhD programs, right? When you are applying to a PhD program, there are two options in our case. You can apply to PhD or PhD with undergrad, which means I only have an undergrad degree and I want to apply to a PhD program. So both are possible in our case. There are choices in our system for that. If you have an integrated master's degree, I think you should go for the standard PhD application, not the PhD with undergrad application, because you have some sort of a master's degree. This is the more general channel. Most of our candidates are coming from people who already have some sort of a master's degree. In any case, we will evaluate your degree. I mean, the courses you took and your success there, it will be evaluated. So it's better to consider yourself as someone having a master's degree. We don't care if it is integrated or not integrated. All of them will be evaluated anyhow.
Thank you, Hocam, for your answer. There's one last question. Can we apply without bachelor's degree since we don't have full transcript?
One way or the other.
You should wait to get your degree and then apply, because our deadline shall allow you to get your transcript, right?
Thank you, John, for the answer.
So basically, by at least the late application deadline, the candidate should provide their transcript.
Thank you.
I have a short comment or short advice for all the candidates when they are applying for a master's or PhD program or a research area. Please consider this consider yourself as you are developing an expertise. It is not only you are like registered to a university as a student, but you are holding an engineering diploma. So you should consider yourself not a student, but a person who is just trying to develop an expertise in an area so that it will become your professional life later on. It is basically something like that. For example, medicine, like doctors are going in a research in an area, for example, eye or like internal, for example, or some other different area. So they develop expertise in that area, and they don't switch actually. So if you put a similarity in engineering, as you do master's or PhD, you are developing an expertise. It is not now being a student, although you are registered, you are admitted, you are acting as an engineer, okay? So you should be really well aware that what you are doing, for example, as like Murat Kaya Hoca said, this is my advice actually. So please be aware why or how, what are you are applying for, and take this degree not as a student, just take this degree as an engineer who is trying to develop their expertise, okay? So it is just my short advice.
Thank you, Taner Hocam, for the advice. And I would like to thank the Professor Erbatur, Professor Tunç, Professor Kaya, and Professor Yapıcı for their great presentation and for the answers. And for any question, also, you can also write your questions to the address shown on the presentation. And again, thank you for joining our webinar. And
thank you. Best
you.
of luck to all candidates.
Yeah. Best of luck. Take care.
Best of luck.
Thank you.
Hopefully see you next year.
Bye-bye.
Bye-bye. Good luck.